So you're buying a pump. What's on your checklist? Flow rate? Head? Price? Delivery time? Those all matter, of course. But here's the thing, there's one factor most people ignore, and it could cost you thousands. I'm talking about centrifugal pump efficiency. Let's break down what that actually means. Your motor puts energy in, and your pump turns that into flow and pressure. Efficiency is simply a measure of how much of that energy is really being used. Higher efficiency means less waste. Simple, right? There are actually three types of losses at play: hydraulic, mechanical, and volumetric, and together, they determine your pump's overall efficiency. Now, why should you care? Here's a stat that might surprise you. In many industries, pumps account for 20 to 50% of total electricity consumption. Think about that. Take a 200 kilowatt pump running 6,000 hours a year. If you boost its efficiency from 70 to 80%, you're not just saving energy, you're saving tens of thousands of dollars every single year. That brings us to something called BEP, or best efficiency point. Every pump has a sweet spot where it runs most efficiently. Run too far from that point, and things start going wrong: more vibration, more wear on seals and bearings, more downtime. So here's a pro tip: always check the performance curve and make sure your pump operates close to its BEP. A lot of factors affect pump efficiency. The impeller is the heart of the machine, its shape, the flow path, even how smooth the surfaces are, all of it matters. One of the biggest mistakes buyers make is oversizing the pump. It seems like a safe choice, but an oversized pump runs off design, wastes energy, and you end up paying for it year after year. A variable frequency drive can help by adjusting speed to match demand, keeping you closer to that sweet spot. That's a smart move. Not all pumps are created equal, either. Different types have different efficiency ranges. End suction pumps typically run between 60 and 85%. Split case pumps can go from 75 up to 92%. And multistage pumps usually land somewhere between 70 and 90%. Choosing the right type for your application makes a real difference. Now, here's something a lot of buyers miss. The purchase price of a pump? That's only about 10% of its total lifetime cost. Energy eats up 70%. Maintenance takes the remaining 20%. So if you buy a cheap, inefficient pump, you'll keep paying for it year after year. Spend a little more upfront on efficiency, and it pays off big time. So what do smart buyers actually do? They ask for the performance curve and check where the duty point sits relative to BEP. They demand test reports, real data, not just promises. They choose high-efficiency motors, like IE3 or IE4. They ask whether the manufacturer uses CFD for hydraulic design optimization. And they make sure the pump is matched to the specific application. That said, efficiency isn't the only thing that matters. In a chemical plant, you need reliability. In mining, you need wear life. In fire systems, you need dependability above all else. So always look at the bigger picture. Efficiency is part of the story, not the whole story. So next time you're buying a pump, don't just ask which one is cheapest. Ask a better question: which one will cost the least over 15 years? The answer, more often than not, comes down to efficiency.